So that should, when we run it, tell us how long it took to call the method or to calculate whether or not the numbers 1001 through to 1999 are prime or not using method 1. And of course we could run it again and swap this for is prime 2. But before we do that, we need to think about those complications we were talking about a little earlier on. So let's first of all think about the idea of native compilation. As we know, the Java Virtual Machine will decide when to compile a method natively, and this will affect the performance of our code as it will run faster if it has been natively compiled. So there are then two approaches to get around this problem. The first thing we could do, and I'm absolutely not recommending this, is we could, when we run this code, say turn off native compilation. Let's not compile anything. You might remember there's a flag that we can use to do that. The flag is -xx : tiered compilation. If we run the code with this flag, then there'll be no native compilation taking place, and we will find out how long our code takes to run without native compilation, but we absolutely don't want to do that. We probably want, in fact, the exact opposite. We want this code to be natively compiled before we start doing the measuring. So how do we do that? Well, we know that native compilation takes place at the point that the Java Virtual Machine has decided this method is being called a lot, therefore it's worth doing native compilation on this method. So the way that we need to do it is actually by calling the method a number of times before we start doing our measuring. And this is known as the warm-up period. So what we would do is say, let's have a warm-up period. And in the warm-up period, we're going to do a loop, and in the loop, we're going to call is prime. And I'm going to do this a number of times. I think we'll go from 1 to 10,000. And hopefully that will be calling this method enough times that we'll know that native compilation has taken place. What we could then do is print out something to the console to say warm-up finished, now measuring. And then at the end, we'll have the time taken, and we're only measuring after the warm-up period. So only measuring after, hopefully, native compilation has taken place. Now we'll need to know, has native compilation taken place or not? So we probably now want to run this with the print compilation flag. So let's go into the run configurations, put in our -xx : print compilation. And we'll run this and see what the results look like. Now I'm going to make my console bigger. And what we'll see here is that there was all sorts of compilation going on during the warm-up phase. And there was no further compilation, at least of the isPrime method, which certainly got, in fact, compiled natively here, by the looks of it, before our main measurement process started. And the measurement process took almost no time at all, actually. It took 2 milliseconds. So that tells us that we fixed, if you like, the native compilation issue. But now we're not measuring enough to be able to get a meaningful comparison. So let's go back to our code then. And what we'll need to do, I think, is say, rather than just testing 1,000 numbers, let's test 50,000. Let's go mad. So we're going to loop from 1 to 50,000. And hopefully that's going to take a lot longer to run. So let's run that again. Good, so our warm-up has finished and now it's measuring. There was no further compilation during the measuring phase, so that's good. And in order to calculate 50,000 prime numbers, or to evaluate whether or not they're prime, that has taken, on my machine, 834 milliseconds. Now we might want to run this a number of times to see if we're always going to get a number that is roughly in that order. I've got 824 there. I think I'll just do one more time here, 822. So we're looking at somewhere between 820, 835 milliseconds to run the isPrime1 version of our method.